Alright, you guys, we are now in Chapter 9. We're looking at Section 1, and we're going to discuss mathematical patterns. We are looking to identify the patterns found in a sequence, and we want to use a formula to find the nth term of a sequence. The main two formulas that we're going to be looking at are explicit formulas and recursive formulas. So first, let's just talk about what a sequence is. A sequence is an ordered list of numbers. Each number in a sequence is a term of a sequence. Now, we've used subscripts before, and we're going to use them again to represent a term of a sequence. So you can represent a term of a sequence by using a variable with a subscript number to indicate its position in the sequence. For example, a sub 5 is the fifth term in the sequence, a sub 1, a sub 2, a sub 3, a sub 4. The subscripts of sequence terms are often positive integers starting with 1. If so, you can generalize a term as a sub n, the nth term in the sequence. So our first term would be a sub 1, our second term would be a sub 2, our third term would be a sub 3, and so on. Our nth term would be a sub n. The term before that would be a sub n minus 1, and the term after that would be a sub n plus 1. So if you see this n minus 1 and n plus 1, it's talking about the term before n and the term after n. Alright, so now let's look at explicit formulas. The word explicit, the definition for it, is stated clearly and in detail, leaving no room for confusion or doubt. So explicit is just another word for straightforward, or clear, plain. So a straightforward formula describes the nth term of a sequence using the number n. Explicit, straightforward. Alright, so problem 1. Generating a sequence using an explicit formula, a straightforward one. A sequence has an explicit formula a sub n equals 3 times n minus 2. What are the first terms of this sequence? So that's pretty simple. This is straightforward. It lets us know that we have this formula and it wants us to find out the first 10 terms. So I could say, well, the first term, a sub 1, is equal to 3 times 1 minus 2. Where I'm substituting in the number 1 for each of my n's. So the n here is a 1 and the n here is a 1 because I'm finding the first term. So my first term is going to be 3 times 1 is 3 minus 2 is 1. To find my second term, I'm going to say a sub 2 for the second term equals 3, substitute in a 2 for n as well, minus 2. So 3 times 2 is 6, minus 2 is 4. And I'm going to continue on because the question says, what are the first 10 terms of this sequence? So I'm going to continue on and find a sub 3, a sub 4, all the way to a sub 10. And I want you to do the same thing. So I'm going to go ahead and pause it and work it out while you do the same. Alright, so here's the rest of my work. So we can see that the first 10 terms of this sequence are the following: 1, 4, 7, 10, 13, 16, 19, 22, 25, and 28. Alright, so now it's your turn. You try. A sequence has an explicit formula a sub n equals 12n plus 3. What is term a sub 12 in the sequence? Go ahead and pause it, take a minute, and then continue on. Alright, so sometimes you can see the pattern in a sequence by comparing each term to the one that came before it. For example, in the sequence 133, 130, 127, 124, each term after the first term is equal to 3 less than the previous term. But in order to find the fourth term here, we would have to know what that previous term was so we can subtract 3 from it. So a recursive definition for this sequence contains 2 parts. An initial condition, the value of the first term, we need to know that. If I don't know what this first term is, then I won't be able to find the fourth term, even if I know that the pattern is 3 less each time. A recursive formula relates each term after the first term to the one before it. So, in this sequence, a sub n, the nth term, is equal to the one before it, a sub n minus 1, minus 3. So for example, 124 is equal to the term before it, 127, minus 3. And that gives me 124. So problem 2, writing a recursive definition for a sequence. The number of blocks in a two-dimensional pyramid is a sequence that follows a recursive formula. What is a recursive definition for the sequence? So we are going to write a recursive formula. We're going to write something like this over here, where we are talking in generalities, a sub n. So our first step is to go ahead and find our sequence. And we can do that just by counting our blocks here. So the number of blocks in each pyramid, the first one would be 1, the next would be 3, next we have 6, counting from that we have 10, then we have 15, and then we have 21. Below each pyramid, I'm going to write which term it was. So this is our first term, here's our second term, here's our third term, here's our fourth term, our fifth term, and our sixth term. I could also write a sub 1, a sub 2, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. Alright, so now we want to find out what happens from one term to the next. So we started our first term and we want to go to our second. So from 1 to 3, we see that to get there, one way we could do it is to add 2. Another way, I suppose, is that we could multiply by 3 to get there. So we want to keep that in mind too. Then from our second term to our third term, from 3 to 6, we're adding 3. From 6 to 10, we're adding 4. From 10 to 15, we're adding 5. And from 15 to 21, we are adding 6. So if we look closer at our pattern, we see that when we go from our first term to our second term, we're adding 2. And that's how we get to our second term. To get to our third term, we're adding 3. And then we're getting to our third term. From our third term, if we add 4, it brings us to our fourth term. So I think you kind of see the pattern there. So if I wanted to get to my nth term, and we will call that a sub n, my nth term, then I know that I would have to take my previous term, so the term before it would be n minus 1, so a sub n minus 1, and I'm going to add to it, well, let's see again. So if I'm at my fourth term, I'm at 10 here, and I want to get to my fifth term, I have to add 5 because I'm trying to get to my fifth term. So I have to add the term I'm trying to get to, which is n. So my recursive definition, it's a two-part. I need the formula. So here's my formula. A sub n is equal to a sub n minus 1 plus n. And I need my initial condition. I need the value of my first term. So the value of my first term, I'm going to put a semicolon here, a sub 1 is equal to 1. And now I have my recursive definition for my sequence. Alright, so now it's your turn. It says, what is the recursive definition for each sequence? So this is number 2 for you, but you have 2 problems in number 2, part A and part B. It has a hint here. It says, look for simple addition or multiplication patterns to relate the consecutive terms. And after you finish these 2 problems, we'll finish the last 2 slides and our classwork assignment for tomorrow. All right, thanks you guys. See you tomorrow.